So today we're going to be reviewing right triangle trigonometry, and I'm going to pre-set up a lot of these problems to make the video a bit shorter, but you might have to pause to copy down some notes. So this is what I've set up for our first slide. I'm going to be doing about half of the problems on both pages. On page 1 I'm going to be doing problems 1 and 4, and on the back I'll be doing all the problems on the left side. So what we're asked to do is, given a right triangle with 2 of its parts known, technically we always know 3 because we know the right angle is 90 degrees, we need to find our remaining side and angles and round all our answers to the nearest hundredth. And we're supposed to identify the 12 trig ratios of each triangle. So starting off, we're going to be working with finding the missing side length. So that is side AB, which I've called x. So to find the missing side, knowing 2 sides of a triangle, we're going to be using the Pythagorean theorem. So that's a squared plus b squared equals c squared, where c squared is the hypotenuse. So in this case, the hypotenuse is 8, because that's what we're given, equals x squared, because that's one of the 2 legs, plus 4 squared. Now, it doesn't matter if I switch the order of x and 4, it's going to give us the same answer. So we're going to get x squared plus 16 equals 64, which gives us x squared equals 48, and we finally simplify that to be x equals radical 48 by taking the square root of both sides. Now, 48 is not a perfect square, so it will become x equals radical 16 times radical 3, because the largest perfect square that goes into 48 is 16. We could do 4 and 12, but 12 would still contain a perfect square. So we're going to get x is equal to 4 radical 3. As a decimal, using a calculator, we can see that 4 times radical 3 is going to equal 6.928. So I'm going to call that x equals 6.93 for this example because of what we were asked to do. And we'll come back to the calculator later when we need it. But for the sake of this problem, I'm actually going to call this 4 radical 3 and work with it as a radical, just to show you some additional things that might come up in your Delta Math assignment. Now, we need to find the sine of A. So in order to find the sine of A, we need to know, firstly, SOHCAHTOA. So SOHCAHTOA is just a reminder of what the trig ratios mean. So sine is the opposite over the hypotenuse. So let's label our triangle appropriately from angle A. So from angle A, the side across from it is the opposite, so that's 4. The side next to it is the adjacent, and the side that is across from the right angle is the hypotenuse. So based on this, we should be using 4 and 8. So we'll get 4 over 8, which when simplified is 1 over 2. So I'm going to be crossing out anything I simplify. Or I'll show the steps. So 4 goes into 4 once, and 4 goes into 8 twice, leaving us with 1/2. So that's our first trig ratio. Maybe let me circle this in purple since the other angle is going to be in red. The cosine is the adjacent side, which is 4 radical 3 divided by the hypotenuse, which is 8. Once again, 4 goes into 4 once, and it goes into 8 twice, leaving us with radical 3 over 2. So that is our second trig ratio. And the tangent of A is going to be the opposite, which is 4, divided by the adjacent, which is 4 radical 3. So both of these are divisible by 4, so they're left with 1s, so we're going to be given 1 over radical 3. And the reason I wanted to do this with radicals is to remind you that you cannot have a radical in your denominator. You have to rationalize the denominator, which means to multiply the numerator and denominator by that radical. Now, radical 3 times radical 3 will equal 3. And the numerator, we have 1 times radical 3, which is just radical 3. So this is our third trig ratio. Now to find the cosecant, secant, and cotangent, that's pretty easy. All we have to do is flip over our answers to sine, cosine, and tangent. So sine and cosecant are reciprocals, so c goes with s, if that helps you remember it. So this would be 2 over 1, which is just equal to 2. So that's our fourth trig ratio. For the secant, we're just going to flip over radical 3 over 2 to get 2 over radical 3. Now we're not allowed to have the radical in the denominator, so we're going to multiply the top and bottom by radical 3, and we will get 2 radical 3 over 3. Now, if the 2 and 3 had any common factors, we would try to simplify, but since we do not have any common factors, this is our 5th trig ratio. And for cosecant, we're going to get 3 over radical 3, and once again we have to multiply the top and bottom by radical 3 to rationalize the denominator. In this case, we get 3 radical 3 over 3, and in this case the 3's both divide by 3, so we're left with a final trig ratio of radical 3. So these are our 6 trig ratios for the angle A in this problem. Now you'll notice I didn't include a section to do angle B, and that's because angle B is the right angle, and from the right angle the opposite side is its hypotenuse, and both legs are the adjacent. So because there's 2 legs, there's no real way to determine which one would be correct to use. So we just can't do it. So now for sine of C, we have to go back to the problem here. And because C is a different angle, it has a different opposite, adjacent, and hypotenuse. So instead of 4 being the opposite will now be 4 radical 3. And the 4 will become the adjacent, and the 8 is still the hypotenuse because it's still across on the right angle. So now based on this label, what's going to happen is sine is going to become 4 radical 3 over 4, not 4, 8. And if we look at cosine of A, that's actually the same thing. So the sine of C and the cosine of C have the same value, which means this is actually also going to simplify to be radical 3 over 2. So the sine of one of the angles in a triangle will be the cosine of the other angle. So that means that the cosine of C is actually going to be 1/2, because it's gonna start off by being 4 over 8, because 4 is going to be the adjacent for this angle, and this is going to simplify again to be 1/2. So pretty much everything that happened in the other one is going to happen in reverse here. So the sine and cosine, or the co-functions, that's why one of them has the word co in it, are going to be opposites. So for sine, we just have to find the sine of C, we just have to look at the cosine of A, and to find the cosine of C, we just have to look at the sine of A. The tangent of C will actually be the cotangent of A, so radical 3. And just to show you that algebraically, if we were to do the tangent of C, we would look at the opposite, which is 4 radical 3 over 4, and then the 4's each divide by 4, and we're left with radical 3. So we get it that way, but once again, it is just the cotangent of the other angle. Now cosecant of C should be the secant of A, so 2 radical 3 over 3, but just to be safe, I'm going to take the reciprocal of sine, so that's going to be 2 over radical 3, and based on the work we did before with 2 over radical 3, which is on the secant of A, we're going to get, by multiplying the top and bottom by radical 3, we're going to get 2 radical 3 over 3. Should really be doing this in red. But I'm really trying to stress that the co-functions are just the opposites for the 2 angles in this triangle. So the once again, just to kind of point it out, so the sine of A was the cosine of C. The cosine of A is the sine of C. The tangent of C is the cotangent of A. The cosecant of C is the secant of A. So based on that, the cosecant of A, the secant of C should be 2. So the reciprocal of 1 over 2 is 2 over 1, which is 2, which is the same thing as the cosecant of A. And the cotangent of C should be the same as the tangent of A, or radical 3 over 3. We can see that by doing the reciprocal of radical 3, which is 1 over radical 3, where we have to multiply the top and bottom by radical 3, which will then become radical 3 over 3. So now these match as well. So now we found all 12 trig ratios, but we still haven't found the angles. Now, in order to find the angles, we need to use one of these 6 trig ratios. any one of them is fine. Technically, we can also use the reciprocal functions, but they're not going to be as useful. Just for simplicity's sake, I'm going to use sine of a. I'm going to take that equation and I'm going to write it, I'm running out of space here. I'm going to write it up here. So the sine of a is equal to 1/2. So if I use the sine inverse feature on my calculator, the sine inverse of 1/2 will be equal to angle A. So that means angle A is going to equal, we should really be doing this in purple because that is the color of the angle I used. So I'll do that just to make things a little more clear. So the sine of A was equal to 1/2, or even if we left it as 4/8 for the sake of finding the angle, we can do that. So A is going to equal to sine inverse of 1/2, which means angle A is going to be equal to, I need a calculator for this part. So we're going to do second sine of 1/2, which is 30, which should make sense because we should know our sine of 30 at this point should equal 1/2 because of what we've learned in the past about the evaluating trig functions. So we get 30 degrees. So that is the measure of angle A. Now finding angle C, we can just use the fact that we know what these three angles are. So we have, let me use orange, I guess. So 30 degrees plus 90 degrees is 120 degrees. And since all three angles have to make, since all three angles have to add up to be 180 degrees in a triangle, 30 plus 90 plus what will make C. So C has to be 60 degrees. And now we found all the sides, all the angles, and all the trig ratios for all the angles in this problem. So we're going to take a look at problem 4 now. We're going to do one more of these, and then we're going to take a look at the problems on the back. You might have to pause or go slow on this in case there's any confusion. So the difference between problem 4 and 3 from 1 and 2 is, in this case, we're only given one side and one angle. So we have to find the side using trigonometry, which means it's impossible to get a radical for our answer. So everything here will be working in decimals. So firstly, we are going to use the fact that we know what angle E is. It's 79 degrees. But knowing that, based on what we just did in the last problem, 90 plus 79 plus angle D have to equal 180, which tells us that angle D is going to be equal to 21 degrees or 11, what is it, 11 degrees? So 90 plus 70, all right, so 79 plus 1 is 80, it's 11 degrees. So angle D is going to be 11 degrees. Now we don't need that right now. So we have to pick one of our two angles we know. It doesn't matter which one we pick. Let's pick angle E because they gave us that value. So we're going to use angle E, and we need to find side K, and we know, I'm sorry, we're going to use the fact that we're going to find side measure, we're going to be doing this in blue, we're going to find the measure of side X, which is side ED, by knowing two sides and the angle. So the angle we're working with is 79, so we're going to write a trig ratio based on that. So in order to write a trig ratio, we need to label the sides. So from, should be really using purple here. So we're going to find this side using this side and this angle. All right. We could technically also do this from the 11. So based on this side, the side across is the opposite, which is not one of the sides we have. So that means we're not going to be using opposite in our problem here. The x is the hypotenuse, and 23 is the adjacent of angle 79 degrees. So we're going to write a trig ratio, which is the, based on what we have here, we have adjacent and hypotenuse, which if we look back at our SOHCAHTOA, adjacent and hypotenuse is C, which is cosine. So we're going to write the cosine of the angle with 79 degrees is going to equal its adjacent, which was 23, divided by its hypotenuse, which is x. And to solve this equation, I'm going to make this into a proportion and cross multiply. I will get x cosine of 79 equals 23. And then to find out what x is, I'm going to divide both sides. Whoopsies, went to the wrong assignment. I'm going to divide both sides by cosine of 79. and I'm going to get that x is equal to 23 divided by the cosine of 79. Let me just use my calculator. 1 minute. Sorry, I picked a bad place to go. All right, so that's going to be 23 divided by the cosine of 79 degrees. I do have to make sure my calculator is in degree mode, which it is in this particular case. And we're going to get 120.54 degrees. Oh, no, that's not degrees, that's a side measure. So that's 120.54 is the measure of this side of this triangle. We will pick up shortly in part